Lesson 27, the Pythagorean Theorem. The objectives and vocabulary for this lesson are: use the Pythagorean theorem and its converse to solve problems, use the Pythagorean inequalities to classify triangles, and your vocabulary word would be the Pythagorean triple. The Pythagorean theorem is probably one of the most famous mathematical relationships. As you learned in lessons 1 through 6, it states that in a right triangle, the sums of the squares of the lengths of the legs equals the square of the length of the hypotenuse. The Scarecrow says this in The Wizard of Oz. So this is a squared plus b squared equals c squared, and we've used it before. Let's use an example. Find the value of x and give your answer in the simplest radical form. First, we start with the Pythagorean theorem. We substitute 2 for a, 6 for b, and x for c. We're going to simplify on the left-hand side. So 2 squared plus 6 squared gives us 40 equals x squared. Find the positive square root because distance is positive. And we get the square root of 40 equals x. Simplifying the radical, we have 4 times 10 underneath the radical. The square root of 4 is 2, so x equals 2 square roots of 10. Another example, we want to find the value of x and give our answer in the simplest radical form. Start with the Pythagorean theorem. Substitute x minus 2 for a, 4 for b, and x for c. We're going to multiply. We have x squared minus 4x plus 4 plus 16. We'll combine like terms, and we get negative 4x plus 20 equals 0. Add 4x to both sides, and 4x equals 20. Divide both sides by 4, and x equals 5. Let's look at a craft application problem. Randy is building a rectangular picture frame. He wants the ratio of the length to the width to be 3 to 1. So the length would be 3 times the width. And the diagonal to be 12 centimeters. How wide should the frame be? We're going to round to the nearest tenth of a centimeter. Let L and W be the length and width in centimeters of the picture. Then L to W is 3 to 1, so L equals 3W. Using the Pythagorean theorem, a squared plus b squared equals c squared, we're going to substitute 3w for a, w for b, and 12 for c. Multiply and combine like terms, we get 10w squared equals 144. Divide both sides by 10. W squared equals 144 over 10. Find the positive square root and round. W equals the square root of 144 over 10, which is about 3.8 centimeters. A Pythagorean triple. This is a set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. Common triples would be side lengths of 3, 4, 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. Identifying a Pythagorean triple. Find the missing side length and tell if the side lengths form a Pythagorean triple, and we're going to explain why. So we have a triangle with the legs are 14 and 48. So first we use the Pythagorean theorem. We substitute 14 for A and 48 for B. We multiply and add, and we get 2500 equals C squared. We find the positive square root, C equals 50. The side lengths are non-zero whole numbers that satisfy the equation a squared plus b squared equals c squared, so they form a Pythagorean triple. Remember that they have to be whole numbers. Let's look at another one. Find the missing side length and tell if the side lengths form a Pythagorean triple and explain why. So we use the Pythagorean theorem and substitute 4 for A and 12 for C. 4 squared plus b squared equals 12 squared. Multiply and subtract 16 from both sides, and we get b squared equals 128. Find the positive square root. B equals the square root of 128, which is 8 square roots of 2. The side lengths do not form a Pythagorean triple because 8 square roots of 2 is not a whole number. The converse of the Pythagorean theorem gives you a way to tell if a triangle is a right triangle when you know the side lengths. The converse of the Pythagorean theorem states, if the sums of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle. You can also use side lengths to classify a triangle as acute or obtuse. In triangle ABC, C is the length of the longest side. If c squared is greater than a squared plus b squared, then triangle ABC is an obtuse triangle. If c squared is less than a squared plus b squared, then triangle ABC is an acute triangle. This is the Pythagorean inequalities theorem. To understand why the Pythagorean inequalities are true, consider triangle ABC. When ABC is a right triangle, the converse of the Pythagorean theorem shows us that the measure is 90 degrees. If c squared is greater than a squared plus b squared, then c is increased. Then by the converse of the hinge theorem, the measure of angle C has also increased, so it's greater than 90 degrees. If c squared is less than a squared plus b squared, then c has decreased. And by the converse of the hinge theorem, then the measure of angle C has also decreased and is less than 90 degrees. Let's look at an example. Tell if the measures can be side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. Remember that we have the triangle theorem that tells us that we have two sides added up together. They have to be greater than the third side in order to be a triangle. So step 1, determine if the measures form a triangle. So 5 plus 7 is greater than 10, 5 plus 10 is greater than 7, and 7 plus 10 is greater than 5. By the triangle inequality theorem, 5, 7, and 10 can be the side lengths of a triangle. So continuing our problem, we're going to classify this triangle. Compare c squared to a squared plus b squared. So is c squared equal to a squared plus b squared? We're substituting the longest side for c. So we have 10 squared equals 5 squared plus 7 squared. We want to know if this is true. Multiply. Is 100 equal to 25 plus 49? Well, we add and compare, and we get that 100 is greater than 74. Since c squared is greater than a squared plus b squared, the triangle is obtuse. Again, we want to try a different set of numbers, 5, 8, and 17. So step 1, determine if the measures form a triangle. Since 5 plus 8 equals 13, and 13 is not greater than 17, these can't be the side lengths of a triangle. So we don't need to even worry about classifying it. Now you try. Find the value of x and give your answer in simplest radical form, so you're not giving me any decimals. Find the missing side length and tell whether the side lengths form a Pythagorean triple. And then tell whether the measures can be sides of a triangle, and if so, classify the triangle as acute, obtuse, or right.